if I keep adding sodium chloride, keep adding sodium chloride solid to this beaker of water and stir it, it dissolves. Is it possible for a point to come where sodium chloride does not dissolve anymore? Can I call that there is a saturation point for any solution where the solution is not going to accept solute anymore? And at that saturation point, some of the solids are dissolving, some of them are precipitating or crystallizing. So the total amount of the molecules remaining in solution, they're constant. Some of them form solid, and some of the solid go back to dissolve. So you have an equilibrium between dissolution and crystallization. That's the point of saturation. Because I'm going to talk about saturation, which means there is a limit of solubility, I better define solubility for you. Solubility is not unlimited. It's not unlimited. It has a limit. How do I define solubility? In this course, we are defining as grams of solute, for example, grams of sodium chloride that dissolves in 100 grams of solvent. That means grams of solute which dissolves in 100 grams of water for sodium chloride, for example. How many grams of certain solute, that's a sodium chloride, dissolves in 100 grams of water? That's our definition for solubility. Of course, this depends on temperature. Solubility of solids in a solvent increases as you increase the temperature. So we define solubility by giving the temperature. And as we said, if you keep adding solute to a solvent, at some point, the solutes are not going to dissolve. We call the solution saturated. And at saturation point, we say there is an equilibrium between dissolved molecules and crystallized molecules. Some are crystallizing and some of the crystals are dissolving. So amount of the solute dissolved in solvent are not fixed. What is the definition of unsaturated solution? It's a solution which still can dissolve more of the solute. It hasn't become saturated, so it is unsaturated. So it contains less than maximum amount of solute. It still has the capability of dissolving more solute. And if I go to the next slide, let's see if we can answer these. Stop the video and look at this question. Pause the video. See if you can come up with the right answer. Okay, let's see if these make sense to you. It says at 40 degrees of Celsius, solubility of KBr is 80 grams in 100 grams of water. Identify the following solution are either saturated or unsaturated. Okay, example. If you are using 60 grams of KBr, we are adding it to 100 grams of water. Is solution saturated or unsaturated? Well, Look at this line. It says at this temperature, you can dissolve 80 grams. And 60 grams is less than maximum amount. Obviously, yes, you're going to have unsaturated, because you still can add another 20 grams of KBr at this temperature and it will still dissolve, so it's unsaturated. On part B, it says we are adding 200 grams to 200 grams of water. Let's look at this 200 grams of KBr. You're dissolving it in 200 grams of water. Can I divide both top and bottom by 2? I get 100 grams of KBr in 100 grams of water. Guys, can we dissolve 100 grams of KBr in 100 grams of water? Look, this says no. It says you can only dissolve 80 grams of KBr in 100 grams of water. So you're adding 20 grams more than what 100 grams of water can handle. So can I say this is saturated? Saturated, number one. And trying to answer part C, what is it asking? If you're adding 25 grams of KBr to 50 grams, so if I have 25 grams of KBr to 50 grams of water, let's multiply top and bottom so I can compare it with the information which is talking about 100 grams of water. If I multiply both top and bottom by 2, on 2. Do I get 50 grams of KBr and in 100 grams of water? Is this, if I compare this information with 80 grams of water, can I say, yes, 50 grams can easily dissolve in 100 grams of water? Because the problem is telling you the solubility of KBr is 80 grams. So this is unsaturated. So part C, this unsaturated, the answer must be 2. I hope this makes sense to you guys. All right. So I'm going to talk about effect of temperature. I think if even without telling you this, you probably know when you're dissolving a solid in water, if it's not dissolving, you're going to heat it. So general pattern is this. You increase the temperature, solubility is increasing, They increase by different amount, but in most cases, increasing the temperature increases the solubility of a substance in the solvent. Are there exceptions? Yes, depending on the geometry of molecules, depending on the charge of the ions. The extent of increase of solubility, increasing solubility, and its dependence on temperature varies from one compound into another. So we need a table. Do you see sodium chloride? Solubility in water is not substantially changed even when we increase the temperature. Which one is doing the maximum change? Can I say K, NO3, this one? The solubility is increasing abruptly when we increase the temperature. So generally, can I say the solubility of most solid increases with an increase in temperature? That's the general pattern. Is there exception? Yes. How do you know what is solubility of any of these substances in water? You won't know. I have to give you experimental result. I have to give you a table. So that's something that you don't need to worry. You don't need to memorize these things. If I'm going to do the next slide, guys, the opposite is observed about solubility of gases. Look here, I'm increasing the temperature. Solubility of nitrogen is decreases as I increase the temperature. Look at solubility of oxygen as I increase the temperature. Solubility of oxygen gas is decreasing. Look at solubility of NO. As I increase the temperature, the solubility of NO is abruptly reduced. Again, this is nothing for you to memorize, to worry. This is experimental data. I must give you the table if I'm asking you questions about these. Okay, go guys, let's see if we can do this one. You can pause the video to think and then come back. All right. Why would a bottle pressure increases? Because as you're leaving a carbonated water, in heat, the temperature goes up. Carbonated water is obtained by dissolving CO2 in water. As the temperature goes up, solubility of CO2 is reduced in water, it's going to come out. So you have more gas particle on the top of the drink, more particle, more collision, higher pressure, that can cause explosion. Part B, why do fish die in water that is too warm? But we said solubility of gases decreases when temperature goes up. What does that mean? Fish need oxygen. As the water is warming up, solubility of oxygen is decreased. They cannot get oxygen and they die. All right, I think this is a good point to stop. Again, I would love for you to make a list of questions. Come and see me. Let's discuss this during my office hour or lab time. Thank you very much, guys. And I hope you have a wonderful and safe weekend. Bye, guys.